was a 5, right? Yeah. I should wear my glasses probably. This is the lesson 2.4 retrieval in our packet. It is on page 36. First up, for each sequence, find the next 2 terms in the sequence and state whether the sequence is arithmetic or geometric, and then create an explicit equation. Big review from Unit 1. We've done this a lot. As usual, the first thing I'm going to check is if this is addition. So let's see, plus 8, but I know it's not plus 8 to get to 36. So if it's not addition, it must be multiplication. 4 times 3 would get me to 12, and then 12 times 3 gets me to 36. Multiplication makes this geometric, and for my explicit equation, f of n equals, starting value is 4, we are multiplying by 3. They don't really say if it's n or n minus 1, so we'll just assume it's starting at step 1, and we will raise the 3 to the n minus 1. Okay, number 2. Once again, starts with the same 2 numbers, so it must be addition this time. Plus 8 gets us to 12, and then plus 8 gets us to 20. Since this is addition, it's arithmetic. And then our explicit equation would be f of n equals, starting value is 4. We are adding 8 each step, and once again, let's say this starts at step 1. This time we put the n minus 1 down next to the 8 instead of raised because it's addition. Next, we have something that's decreasing, and I can already tell that it's not going to be subtraction because 160 to 40 would be minus 120, and it's definitely not 120 to get from 40 to 10. So it's not subtraction, it must be multiplication by a fraction. So I'm going to think of this in reverse. If it was 10 to 40 and then 40 to 160, that would be times 4. And if you can't figure that out in your head, just go to your calculator and type in 40 over 10. Going backwards, it's times 4. So going forwards, it's times 1/4. So that's geometric. F of n equals 160 times 1/4. And we're going to raise the 1/4 to the n minus 1. All right, last but not least, to get from 20 to 40, it's either plus 20 or it's times 2. To get from 40 to 60, it looks like this one has to be plus 20 for it to work. So that's arithmetic. F of n equals, starting value is 20, adding 20, and n minus 1. I did a lot of that in my head, but if you need to, you can use a calculator. Like figuring out that this is plus 20, just go to your calculator and type in 60 minus 40. If you just haven't had enough coffee to do mental math, that's totally fine. Okay, the next set of questions says to rewrite each expression using the rules of exponents. So I'm going to do the first one expanded, and then we'll see if we remember some of the rules without expanding everything after that. So 7 squared, that'd be like 7 times 7. 7 cubed would be like 7 times 7 times 7. That is 5 7s being multiplied together, so I can rewrite that as 7 to the 5th. So the shorter way of doing that, if we're multiplying the bases, we add the exponents. But of course, you can always expand it, just like I used to do until my math teacher told me to stop it. Next one, I'm not going to write this all out. You can imagine there are 5 13s on the top of the fraction, 2 13s on the bottom of the fraction. 2 sets of 13s are going to cancel out. That leaves us with 3 13s. The shortcut when we're dividing is to take the top exponent minus the bottom exponent, so 5 minus 2. Okay, next, super easy. Anything raised to the 0 is 1. Kind of seems like a random math fact that you need to know, but you'll actually see why that is in a future lesson coming up. And last but not least, 3 raised to the negative 7. Okay, now I don't think we've gone over one of these in a retrieval yet. When you have a negative exponent, you can make it positive by moving that base to the bottom of the fraction. So we can make this positive by rewriting it as 1 over 3 to the 7. Once again, an exponent rule that if you don't remember, it's okay. We're going to cover in a future lesson.